It looks upside down. It's okay. Okay, well, I'm just waiting to see if some of you would join me as participants, but so far I have no one. But you might be viewing on YouTube, or you may be viewing later on YouTube, and that's fine too. So I'm just going to start going over the entire review. Hopefully we'll have no internet problems this time because I'm at home. I usually don't have internet problems. So, and if anybody joins us, you can ask questions. So that's the nice thing about actually participating. Okay, I'm going to start the review sheet number 1. Kind of have a shadow here today. A, 5m minus q equals rm plus c 4m. Well, what we're actually doing here is solving for m. These are called literal equations. And so you got lots of variables, and you just want to solve for one individual one. Now I'm going to go over all of these, but if you continue to have problems, there's also one of these in a video in your lesson this week under the test information that you can watch as well. But what we're going to do here is just what we would do with numbers. We treat the variables like they're numbers. And we want to get the m by itself. Well, we have an m here and an m here. And so we got to group them together. So we're going to move the m over here by subtracting rm. So I'm going to subtract rm from both sides. These will cancel here, and now I'll have 5m minus rm minus q equals c. Well, we don't want the q hanging out over here with our m, so we're going to add q. Q's cancel. I get 5m minus rm equals c plus q. But the whole idea was to get m by itself, so what we want to do now is to pull out the m. So we're actually taking out like a greatest common factor of m, and we'll be left with a 5 minus r equals c plus q. And now again, we want the m by itself, so we're going to divide by this binomial, this 5 minus r, which will cancel here, and have it over here. And this is your answer right here, the c plus q over 5 minus r. Okay? All right, next one is the b. We have 2 over d minus 3 over e equals 5, but we're solving for e. Okay, there's that e. Well, the thing you need to remember when you have fractions, because these are fractions, right? So we have a d as a denominator and an e as a denominator. We need to multiply the entire equation by the least common denominator, which in this case would be dE. So I'm going to multiply everything times dE. So here the d's cancel. I'm going to get a, you know what, I'm going to do this different. I'm going to put this extra step in here so you'll see exactly what I'm doing. So I'm multiplying dE over 1. So this is the numerator times the numerator. The denominator times the denominator. 1 times d. That's where I got that. Now 3 times dE and 1 times e in the bottom, okay, equals 5 dE. And you'll notice here the d cancels and I get 2e. Here the e's cancel and I get minus 3d. And over here it's still 5 dE. And now I'm trying to solve for e, right? So I want the e's all over here. I'm going to subtract 5 dE from both sides. Here it's going to cancel. Here I'm going to have 2e minus 5dE minus 3d, and over here we have 0. Well, we want to get this one out of here because it doesn't have an e in it, and that's what we're solving for. So that's going to cancel. I'm going to have 2e minus 5dE equals 3d. Let me move this up so you can see it. Okay, now, again, the procedure when you have something like this is to factor out that e. So now I got 2 minus 5d equals 3d, and I'm going to divide away the 2 minus 5d and divide it over here. So e equals 3d over 2 minus 5d. And that's your answer for 1b. Okay, next one is going to be C. And C has many parts, so we're going to do the I part first. But the original literal equation is 6a minus b over f plus 1 equals a. And for the I part, we're going to do it for f. So we got to get rid of the fraction. And my common denominator is just f plus 1 because that's the only denominator I have, right? So I'm going to multiply everything by f plus 1 times 6a minus b over f plus 1 equals a times f plus 1. Well, over here we can see very clearly that those cancel. So we have 6a minus b equals, and now I can distribute my a, so I'm going to have af plus a times 1 is a. And I'm still looking to solve for f, so I want the f here by itself. So let's move the a over. I'm going to subtract a. Here, this is going to cancel. Here, 6 minus 1, right? That's like a minus 1 is 5a minus b equals af. I want f by itself. I divide by a, and this is our answer. But you'll notice in the key that they actually separate this. So you can go from here to here. That's 5a over a minus b over a. And here the a's cancel, so that becomes 5 minus b over a. Okay? I would accept either of those answers. All right, that's the I part, but now we got the double I part. We're still using this same equation, but this time we're solving for a. Well, when you first look at this, you go, well, a equals this, but no, you have an a in here. So you got to get all the a's together. That's not going to work. But we're going to do the very same thing that we did in the beginning. Always, if you have a fraction, you get rid of the fraction. So I'm going to multiply everything by f plus 1, okay? That cancels. I get 6a minus b. Over here, I get a times f plus 1. All right, so I'm going to distribute my a now. I got to distribute that before I can do anything else. So I got af plus a. Okay, so I got a bunch of a's over here. I got one stuck over here. Let's take it over to this side. I'm going to cross that out. Negative b equals af plus a. And so now factor out your a, get f plus 1, divide by, I did that wrong. A minus that is negative 5a. So factor out my a, I'm going to get a negative 5 here. That's because a plus negative 6a is negative 5a. Okay, so now we're going to divide by a. No, we're going to divide by f minus 5. Divide by f minus 5. So a equals negative b over f minus 5. And you could multiply the top and the bottom by negative 1 so that we don't have a negative on top. So we'll end up with a positive b over 5 minus f, which is what they give in the answer key. Okay, I'm going to pause just for a minute and I'll be right back. Okay, sorry about that. I just wanted to make absolutely sure that we were broadcasting after what happened the last time. And I've got, oh, I do have one person on here. So hello. If you want, you can send questions on the chat. I will send you a chat. Oops, spelled chat wrong. All right. So now I'm going to go on to the triple I. I'm still using the same literal equation, which is 6a minus b over f plus 1 equals a. And now we are solving for the triple I for b. So b's right here. Okay, I got to get that separated. Well, first, again, always get rid of your fractions. So we're multiplying by f plus 1 over 1. The f's cancel. You end up with the f plus 1 cancels. And the 6a minus b is what's left. But we're also multiplying this side by f plus 1, because whatever you do to one side of an equation, you always have to do the same thing to the other side of the equation. And so now I'm going to distribute that a. So we got to get rid of parentheses. And I got a bunch of a's over here, so I'm subtracting 6a. So a lot of this should look familiar from the other problems I just did on this one. So now I have negative b equals af minus 5a. Okay, but I'm trying to solve for b this time. So in this time, I don't need to distribute the a out, because all I need to do now is multiply both sides of the equation by a negative 1, because we can't have a negative variable. So now we got b, and if I multiply by this by negative, this by negative, it gives me positive. That's my answer. And you also could rewrite it in the other order. So you might have 5a minus af as your answer. Okay. And the very last one is D of this number 1. D. And we're going to solve. We got x equals y2 minus y1 over z plus 4. And we're going to solve for z. Okay, so we want to get z by itself. Again, a fraction. We're going to multiply everything by z plus 1. Nope, z plus 4 over 1. That's x equals y2 minus y1 over z plus 4. Well, here it's just x times the z plus 4. Here the x plus 4 is going to cancel, and I get y2 minus y1. So now I'm going to distribute. I'm going to have xz plus 4z for x equals y2 minus y1. All right, so remember, we're solving for z, so let's just pull the 4x over here. Subtract 4x. That's going to cancel, and I'm going to have xz equals y2 minus y1 minus 4x. Want z by itself, so divide by x. And that is your answer for that particular problem. You can actually separate this, because it is what they do here on this in the answer key, like this, and this is 4x over x, and then the x cancels. So you end up getting y2 minus y1 over x minus 4 as your answer. Okay. All right, so that takes care of number 1. I lost my one viewer. I don't know where they went. Okay. So now let's go to number 2. Number 2, we're going to get into our linear functions and creating slope and equations and things like that. So we're given 2 points. We're given point A is 2, 5. And we're given point B is -3, 2. So first question, A, find slope. Well, slope is the y2 minus y1 over x2 minus x1 formula. Yes, you're going to need to know that formula. So I'll call this x1, y1, call this x2, y2. I'm going to say 2 minus 2. I'm sorry, minus 5 over -3 minus 2. So I got to do my y's, then my x's. And I get -3 over -5, which becomes a positive. Negative over negative is going to be a positive 3 over 5 for that one. Then for B, we're finding distance from A to B. So our distance formula tells us that we're going to subtract these and then square them. 2 minus a -3 squared, add it to 5 minus 2 squared, and it's all the square root of. Okay, so yes, you need to know that formula. So right here becomes a double, that double negative comes a plus. So you've got 5 squared there, which is actually 25. Here you got 3 squared, that's 9, square root of. So we get the square root of 34. And they do not ask you to take that down to a decimal, so that is your answer right there, square root of 34, distance. Okay, let's do C part. C asks us the equation. So now we got to use our point slope, equation of a line. So we got y minus y1 m, which is slope, times x minus x1. You can actually use either of these 2 points. I'm just going to use the first one, but you can use either for the x1, y1, and then of course your x and your y is your variable that stays a variable, and your slope is what we found up here, 3 over 5. So what we end up with is y minus y1 equals 3 over 5 times x minus 2, my x up here. So y minus 5, and I'm going to distribute my 3 over 5. And this is just multiplying fractions across the top, across the bottom. And now I have to add 5 to both sides, and this is where some students have difficulty because they're adding a whole number and a fraction, but you should be able to do that. If you can't, you can put it in your calculator, okay? So I can show you on your calculator. Let me put this here, see if you can see it this time. I think you can. Okay. So if I'm adding 5, I think I'm adding 5 to negative. Okay, so 5 plus a negative 6 over 5, isn't that right? Yes, 6 over 5. Well, it's hard to see. Maybe if I do that. Okay, negative, and you do 6, ABC, your ABC button right there. ABC, that creates your fraction over 5, and hit enter. Tells you it's 3 4/5. We probably want that in an improper fraction, so you can go back and hit second, and that ABC button will change it to an improper fraction. Second ABC, 19 over 5. Do plus 19 over 5, and that happens to be the answer to that problem, okay? Okay, so now let's go to D. D asks you for the slope of the perpendicular. Well, your slope of this line was 3 over 5. Well, if you want the perpendicular, you take the negative or the opposite inverse. So what you do is you flip it. Perpendicular slope would be 5 over 3, and since this is positive, it will be negative. Okay. then your E part says the equation of the line parallel to the line AB. Well, if a line is parallel, then it's going to have the same slope. So we're going to use this slope right here. Okay. And we're going to have a new x1, y1. So this is a different line, but it has the same slope. It's parallel. So we're going to do the y minus y1 equals slope, parallel slope, times x minus x1. And then I'm going to double negative, change that to plus 2. This is going to be 3/5 times x plus 1. Now I'm going to distribute my 3/5 x plus 3/5. Okay. And subtract 2 from both sides. And again, we're going to have that issue with your fractions. You can also do the fractions by hand, knowing that you're going to have to change it to a least common denominator. So since this would be over 1, I have to multiply top and bottom by 5 and get 15 over 5 minus 2/5 and get 13 over 5. If you do it in your calculator, you should get the exact same answer. And actually, I don't have the right answer because it's 7/5. So let me go back and see. I must have done something wrong. Oh, I know why. Minus 2. And why did I make it 3? So that was not smart. So instead of that, this is going to be 2 over 1. It's going to be 10 and minus 3/5. I switched the numbers. Okay, and so I get 7/5. So your equation is going to be minus 7/5. I just wanted to make sure. Okay, there's your equation. Okay, so that was E of 2. So that brings us to number 3 now. Number 3. We have an equation that's 10x minus 2y equals 6. We want to know the line perpendicular with an intercept of 8. Whoa. Well, if we want the perpendicular to this, we first have to know what this slope is. And the way to find that out is to solve for y so that we get it in the y equals mx plus b format, so you will know that slope. Okay? So I'm going to first subtract 10x from both sides. I'm going to get negative 2y equals negative 10x plus 6. But I still have to have y all by itself, so I'm going to divide everything by negative 2. Cancel those. Now I get y equals 5x minus 3. So my slope here is 5. My perpendicular slope is going to be 1 over 5 and negative. Does that make sense? Right? The inverse, the opposite inverse. Okay, so now I know my slope, and they already gave me that point, which is 0, 8, right? That's my B. It tells me that's my y-intercept. Well, then this is going to be a little bit easier because we're just going to throw in slope and throw in our y-intercept. We don't have to go through the point slope formula to create this one. So I'm going to have y equals my slope, negative 1/5 x plus 8. Okay, so now let's go to B in number 3. And we want the x and y intercept points. Okay, so when you have an equation that's in the format like this, which is what we call standard format, we can easily find x and y intercept because to find x intercept, y is 0. So to find x intercept, I'm going to set y equal to 0, and then I'm going to solve for x. And so I'm going to get 10x equals 6. So my intercept here is 6 over 10 or 3 over 5. Okay, so that's your x-intercept. And written as an ordered pair, you would have 3 over 5, 0, because 0 is what you put in for y. Well, to do your y-intercept, you're always going to put in x equals 0. So we're going to put in 0 for x and solve for y. So we get negative 2y equals 6, so y equals negative 3. And my ordered pair for that would be 0, negative 3. And so that is 3b. So we need to go to 3c now. 3c asks us to get the distance. So it's the same process that we did in the last problem, but you're doing it between the 2 points that we just found, the y-intercept and the x-intercept, okay? So we've got 0, negative 3 for the y-intercept and 3/5, 0 for the x-intercept. So I'm going to do the square root of, and I'm going to have this minus this, that's 0 minus 3 over 5 squared plus negative 3 minus 0 squared. It's all square root of. So here I'm going to have a negative 3 over 5 squared. So that's going to end up being positive, and it's going to be 9 over 25. Here I'm going to have negative 3 squared, that's going to be 9, and we got the square root of that. Okay, so at this point, though, you got to add those fractions and then take the square root of it. Okay. This right here could also be done as a decimal, which that probably would have been an easier way to handle it. So let me go back here. The square root of 0 minus 0.6, because 3 over 5 equals 0.6, right? 3 over 5 converted over 10 multiplied by 2 is 6, so it's 0.6 squared, and then of course this was the plus 9. That becomes, when you put it in your calculator, 0.36 plus 9, so the answer here is the square root of 9.36. Okay. All right, and the D part. So let's go to another sheet for the D part we're going to graph. Okay, so what we have in order to graph is those 2 points, right? We have the x-intercept, and we have the y-intercept. And so if we create ourselves just a quick little grid here, let's say that's 1. Let's say that's negative 1, negative 2, negative 3. That's my y-intercept. My x-intercept is going to be right about there because it's 3/5. And then connect my dots. That is the equation graph. All right, so that's 3. We need to go to 4 now. So let me find my number 4. Okay, number 4. We're given 2 points. Our 2 points are negative 1, 4, and 3, 7. For A, we're asked to find the equation of the line passing through the 2 points. So we're going to use this equation, but that's point slope. This time we don't have slope yet, so we're going to have to actually calculate slope first. So we're going to do that y2 minus y1 over x2 minus x1. That's going to be our slope. So I'm just going to say x1, y1, x2, y2, and 7 minus 4 over 3 minus a negative 1 equals 3 over 4. So it looks like my slope here is 3 over 4. So now I'm going to come and just pick 1 point. So I'll just pick this one. I'm going to say y minus 4 equals 3/4 x minus the negative 1. And get rid of that double negative. So I got x plus 1. I'm going to distribute. And now I'm going to add 4. So you can do that in your calculator or by hand, but your equation becomes 19 over 4 plus 19 over 4. So that's the equation of that line. So the B part says, what is the slope and the y-intercept? Well, we just found it in slope-intercept form, so there's your slope right there. That's slope. And that's your B, or your y-intercept. So that's the answers for B. C is a distance again. So you want a distance between these 2 points. So we have those 2 points. And let's see if I can, I was trying to move this around so I could, let's try it this way. Okay, so I can use this space. I'm going to use these right here, and I'm going to find distance. So square root of negative 1 minus 3 squared plus 4 minus 7 squared. That's going to give me the square root of, that's a negative 4 squared. It's going to be 16. That's going to be negative 3 squared. It's going to be 9. That's going to equal a square root of 25, which actually is 5. And so your answer is 5. And we have one more part of question number 4, D. Find the midpoint. Okay, so let's see if we can remember how to do midpoint. And yes, you're going to need to know midpoint formula so you can do that on this test. All right, so we're going to do the same 2 points. So we've got negative 1, 4, and 3, 7. And midpoint formula tells me that I am going to have an ordered pair. This is going to be my x, this is going to be my y. The way I do this is I add these 2 together and then divide by 2. So I've got negative 1 plus 3 divided by 2, and then for the y, 4 plus 7 divided by 2. So what I'm going to get here is 2 over 2, and like I have 11 over 2. Okay. And so you can reduce those down as 1 and 5.5. And that's your answer to that one. That's the 4D. Okay, this brings us to our Excel portion. So I'm going to go over the Excel. I'm going to screen share one of my windows, which is the Excel that I pulled up. So you should be able to see this now. So, and this was just the key that was posted with the review, but I really wanted to go over this because the last time I did go over it, but you guys never saw it because my internet went out at work. Well, you need to make sure that you do things that I'm seeing people not do in their labs. So on Excel 3, you learned how to do this predicted value here, okay? Some of you did not even create this column. If you don't, you're going to lose a lot of points. You have to create this column. Well, this column comes from this equation down here, okay? This equation down here is what you created with a trend line. Now, most of you got this, the trend line, which is good. So you just right click one of these points, click on trend line, and then you just say, place it on my graph, and here it is. That is coming from the data that you inputted, right? And how you created this graph. But now we're going to do a predicted value column here. And in here, you're going to put this equation, but in a way that Excel understands it. So you're going to take the number times, which is that little star, a cell reference, which in this case is the A4 here, minus 19,547, which that's part of the equation, okay? Once you get that equation, you pull down with this little cross, right? You just hold your left mouse button down and pull it down, and it'll fill in every one of these with the equation or the formula, as Excel calls it, and the correct cell reference for each one of them. That's what I need to see. Now, then you've got the issue where you have to learn how to find an X when you're given a Y, okay? So in this case, they said if you had this right here, let's go back to, I'll go back to looking at exactly how the review sheet actually shows you to ask you to do it. Okay. So C part. So B part is not hard because you just put in 19 here, and if you pull down your equation or your formula, it'll just fill it in for you. And then you'll come back here and say that the predicted value for grade 19 is that amount of money. No big deal. Just make sure you do this on your test. You insert a text box, okay? So you can go up to insert and find text box and put it in here and write out your sentences, okay? I did have some of you that did not do that, and you lost a lot of points on your lab. But when you get to this one, okay, now they're giving you the Y value, the income, okay? That's your Y values along in your chart. So this time you got to use something called goal seek, right? So you would go in here, you'd pull down, you'd have to have the formula in there. You go in here, you go to data. You've got to do this on the test because you can calculate it by hand, but I'm not going to accept that. So then you're going to go to what if analysis because you're learning to use this, and you're going to go to goal seek. When you go to goal seek, it knows that you're wanting to predict this value here. Your to value is that 60,000. So you put in your 60,000, and then you want to change your cell. This one, this is the one you want it to appear in. That would be your X value. So you'd say A12. And you hit OK. And there you said, okay, yeah, I got everything right. Let me hit OK. And it will pop up with this value for you. And then you will then interpret, meaning writing a sentence, putting it in a text box. And you will say that if the income is 60,000, then the highest grade attained would be 23.7. Okay. Or maybe you might want to say 24, but something like that. All right. Okay. And the last one is interpreting your slope. Some of you had trouble interpreting slope, but slope is always your change in Y over change in X. So your Y here is mean income. So that slope, which comes from right here, it's just right in front of the X, that's your slope always if it's Y equals. So this will add that amount of money, $3,352.3 to each mean income, each grade level that you attain. Okay, that should say level right there. But to the mean income. So it's per 1 year. That's what that slope is, over 1 per 1 year. So your change in X is under right? It's in the denominator. And so that's the way you would interpret that. So I hope that helps with the Excel portion. And we have one more thing to go back to. So let me stop sharing and go back to now. We've got one last problem to do, and it's 4 examples of systems, solving systems. Yes, you will have them on the test, and you need to show your work. If some of you know how to do these with using matrix on a calculator, you can check your work with that, but you certainly cannot just give me an answer and get credit. Okay, I have to see your work. So first system is a 2-variable, 2-equation system. Okay. You could do this a number of ways. Because of the way this is set up, I think I'm just going to go ahead and solve it using the what you would call either the addition or elimination method. And I chose to multiply my first equation by -2. I'm going to eliminate my x's, okay? So what I get here is -4x minus 6y equals -8. And then I'm going to rewrite this second equation under it. I'm going to cancel my x's. I'm going to have a -8y here. I'm just adding together now. Off the screen here. Let's move this over. Okay, so you can see it. And -8 plus 5 is a -3. And so when I divide by -8, my y becomes 3/8. So I've got the first part of my ordered pair, that is the solution. And I have to take that and put it back into one of these equations for y. And I chose to just use the first equation. So I had 2x plus 3 times 3/8 equals 4. And I'm going to solve. So I got 2x plus 9/8 equals 4. I'm going to subtract the 9/8 from both sides. I'm going to have this, right? I got to do this either in my calculator the way I showed you, or do it by hand by creating this as a common denominator fraction. So I'd end up with 32/8 minus 9/8. And I get 23/8. But remember, this is 2x equals 23/8. So now I'm dividing by 2. So I'm going to write that like this here so that I can divide with fractions. So that's flipping and multiplying. Again, you can use your calculator. And so I get 23/16. And I believe that's the correct answer to that one. Okay. Yep, 23/16. Well, put it back up here. 23/16. Okay, so that's 6A. We're going to go to 6B. Six B is also a 2-equation, 2-variable. Okay, so these are not quite as bad as the next two we're going to do, which involves 3 variables and 3 equations. Now this one, because I have that y that's all by itself in the first equation, I'm just going to solve for that y by subtracting the 2.25x. Okay, so I'm going to now use that in the second equation. The thing is, when you use substitution, you can't substitute it back in this equation. It won't work. So you created it from the equation number 1. I'm going to put it in equation number 2. So we've got 3.25 times 4.75 minus 2.25 x, and that equals 10.25. And now I have to go through and multiply. So what I get is 1.25x minus 15.4375. So some kind of nasty numbers here. Plus, and the problem is with these, if you do one thing wrong, you mess up the whole thing. So you got to be careful. Like, for example, negative times negative is positive. If you made that negative by accident, it would throw the whole problem off. All right, so I can combine this x and this x, and I'm going to get 8.5625x. And then I'm going to add this to both sides. And I get this. And then when I divide here, believe it or not, this works out to be a 3. So that's kind of nice. And then I just take one of my equations. In this case, once you've got the x is 3, you can use either equation. I just use the top one and put 3 in for x, and I'm going to find y. And so I get 6.75 plus y equals 4.75. And I subtract the 6.75 from both sides. And I get that y equals -2. So my ordered pair here is 3, -2. And that's my answer. And of course, when you get an answer, you can always go back to check it to make sure you're right and put it back in. The x here would be 3. This is -2. Does that work out to 4.75? Then do it again in this equation, and if it works, then you know for sure that you've gotten the correct answer. Okay, so we have 2 more. And the next one is 6c. And here we have 3 equations and 3 variables. So we're going to be looking for an x, y, z ordered pair. Okay. So I've got x plus 2y minus 2z equals 3. I've got 2x minus y plus 3z equals -5. And I have 4x minus 3y plus z equals 7. Now, I like to label these so that I don't get confused. So I've got equation 1, 2, and 3. The whole key to working with 3 equations, 3 variables, is to eliminate one variable and create 2 new equations that are only 2 variables. So then once you get there, it's just like working a 2 variable 2 equation. So I'm going to, in this case, I'm going to add, let's see, I did 2, I did 1, and then I multiplied. So I took equation 1, and I didn't change it. Then I did equation 2, I actually multiplied by 2, because then that's going to eliminate the y, right? So now I have 2 is 4x minus 2y plus 6 equals -10. This cancels. I got 5x here. I'm adding now. Here, that's a z. Don't want to lose my z. This cancels, and I get plus 4z equals -7. And I'm going to call this equation number 4. I've created a new equation that doesn't have a y, has only an x and a z. Okay. Now, I've got to do that again. And so I ended up using equation 2 and 3 this time. But I did it a little different. I took my equation number 2, the original one. Now remember, I have to get rid of y. And equation number 4 over here has a minus 3y. So I'm going to multiply this thing by a 3. And so I get, whoops, negative 3. Because I want this to be positive to cancel this out. So I'm going to say negative 6x plus 3y plus 9z equals a positive 15. That is going to be minus. Just going to make sure I got all these right, because if I don't, I'm going to mess up. Okay, so this is still equation 2, just changed, and I want to add it to equation 3. So that's 4x minus 3y plus z equals 7. So here I get a negative 2x. The y's cancel. No, adding these, I get a negative 8z. And adding here, I get a 22. This is my equation number 5. So now, if I take these two equations, I want to now try to cancel, say, an x or a z. Well, what I decided to do was to cancel the z by multiplying this equation by a 2, right? Because that gives me a positive 8z, and that's a negative 8z. So here I multiply through. This is still equation 4, but I'm going to multiply it by 2. So I get 10x plus 8z equals negative 14. And I'm going to bring equation 5 over here. Negative 2x minus 8z equals 22. I'm going to cancel there. Okay. This becomes 8x, and that equals 8. Divide by 8. I have now gotten my first solution. I know that I have a 1 for x. Now it gets easy, okay? Once I get that, that's really easy. I can take and put this back into one of my equations, my 4 or 5, to find the z, right? So I decided to use this one right here. And I put in, actually, might be negative 7. I mean, it really doesn't matter, but I think I did equation number 4. Okay, so I used equation number 4, the original equation number 4, this one right here. And so I said 5 times 1 plus 4z equals negative 7. So I get a 5 plus 4z equals negative 7. Subtract my 5, I get a negative 12. Divide by 4, and I get z equals negative 3. Okay, so now I know z. So my ordered pair now is this. I don't know why, but I know z. And now I can just pick an equation. And I just picked one of the original equations, which is 2. I used 2. Equation number 2 is 2x minus y plus 3z equals negative 5. I'm going to take that in what I know. I know 1 is x. I don't know y yet. I know z is negative 3, and that equals 5. So I got 2 minus y minus 9 equals negative 5. So I've got negative 9 minus 7 equals negative 5. I'm going to add 7 to both sides, and I get 2. So negative y is 2, but I have to multiply by negative 1 to get the positive variable. I get y equals negative 2, and that's my answer. Okay, so that's one. Let's do one more, and we will be done. 6D. 3x plus y. Oh, I'm sorry, I didn't put the first one. X plus 2z equals 7. 3x plus y plus 5z equals 19. And negative x plus y minus 2z equals negative 7. Okay, now with this one's a little bit easier because looky there, you've got something that you can really work with there because you got that x by itself. You don't have a y in there at all. So you could actually do some substitution here if you'd like to do it that way. I decided to stick with the adding or elimination method because I found it real convenient to go ahead and do 2 and 3 because they already have the y's, right? So all I had to do was multiply this by a negative 1. And so this is equation 1, 2, and 3. I took 2 and didn't change it. I changed 3 just by changing the signs. Okay, and then I add, and this cancels. I get 4x plus 7z equals 26. So I already have now 2 equations that have just x and z. And that's really nice. So I want to maybe cancel the x. So multiply this by negative 4 so I can cancel this. So what I'm going to get when I multiply this by negative 4, this is my equation 1, negative 4x minus 8z equals negative 28. And then this is my equation number 4 I created here. I've got 4x plus 7z equals 26. These cancel. Here I get a negative z equals negative 2. Multiply both sides by a negative 1. And I get z equals 2. So I already have now one of the components of my triplet. So now it gets even easier because I can take this original equation and put in what we know for z and find x. So I'm going to put in a 2 for z, and I'm going to subtract that 4, and my x is 3. So now I've got that, and now I just have to plug it into one more equation and find y. So I don't know, any of these would work. I think I could just use negative x plus y minus 2z equals negative 7. And I'll put in an x. It'll be a negative 3. I don't know why. Negative 2 times 2 for z. And I get negative 3 plus y minus 4 equals negative 7. I add these together, get y minus 7 equals a minus 7. So add 7, and I get 0. So y is 0. And that's my triplet for that last one. Okay, so you do know you're going to do one problem at least that is 3 equations, 3 variables, and they take a lot of time. So you really need to budget your time on this test. I don't know if you just want to do those first or do them last. That strategy is up to you, but look over your tests before you even start and decide what you want to do first so that you can make sure that you get done with everything. Okay, and again, once you get this answer up here, you can definitely put this all back into each one of the equations to see if it works and make sure that you've got a right answer. So I wish everybody well on this test, and thank you for joining me.